out frequencies. Coupled with timers are 5 input capture and 5 output compare PWM modules. First, we'll take a moment to discuss the input captures. Input capture modules are used to measure the time between two events. More specifically, it measures a pulse width from edge to edge, or from edge to every second edge, and so on. The resolution of the input capture is the minimum instruction cycle time, or TCY. TCY is twice the oscillator period. The input capture modules can use either timer 2 or timer 3 as their time base. Shown here is the block diagram of the input capture module. There are a couple of points we should look at. Specifically, the input capture FIFO and the interrupt configurations. While Microchip 16-bit controllers all have a fast, deterministic 5-cycle interrupt response, it's always nice to minimize the number of interrupts. The input capture module contains a 4-level FIFO that works with the ICX con register to minimize interrupts. The input capture event itself can be set via the ICX con registers. The capture can be set to occur based on a combination of rising and falling edges as shown in the table listed below. One special case with the interrupt capture is that it can be set to act as an interrupt while the device is in sleep or idle modes. The module can be set to interrupt the processor every capture event, or every second event, third event, or fourth event. The input capture is an easy-to-use and efficient pulse measurement peripheral designed to minimize the load on the MPU. In association with the 16-bit timers, Microchip includes several channels of output compare PWM on each device. The PIC24 FJ128GA family used in our block diagram contains 5 channels of output compare PWM. The output compare modules can be used to generate single pulses, multiple pulses, and variable pulse chains. The output compares are very useful in lighting, motor control, and even voice reproduction applications. As mentioned earlier, the PIC24F families we are discussing have up to 5 output compare PWM channels. Timer 2 and Timer 3 can be used as a time base for each channel. Each channel uses a 16-bit register for compare. In the next slide, you will see that a secondary output compare register has been added to allow pulse generation with reduced interrupt service requirements. The minimum pulse width is TCY, or 2 times the oscillator period. Several compare modes are available. Set, reset, and toggle can be triggered by the output compare. Single pulse and continuous pulse modes have been added to allow the output compare to operate with minimal CPU intervention. Finally, PWM mode is available. We will touch on this mode in a little more detail in the next few slides. The output compare block diagram is shown here. The key differences between the output compares on the PIC24F and the output compare that you are used to on the PIC18s is the addition of the OCX RS, or the output compare secondary register, and the addition of the ability for dual compare for single pulse and continuous pulse modes. To generate a continuous pulse with an additional low signal, the time for the rising edge would be loaded into OCXR, and the time for the falling edge will be loaded into the secondary register. The output compare mode in OCM0 to OCM2 of the OCX con register would then be set to 101. The benefit of the secondary register and the additional modes is that the load on the MCU is reduced, and very short pulses can be generated because there is no need to load a second register. The double buffering allows glitchless PWM output. The PWM can now cover a full range of 0 to 100% duty cycle over a large frequency range.